Welcome to Excel Data Analysis video number 2, where we get to learn how to use Power Pivot and create DAX measures. Now we're going to create these 4 different reports and a visualization. Now we already did this last video, but in that video we used a standard pivot table and worksheet formulas. Now in last video we learned some great importing data skills with Power Query. We'll build on those in this video. We also saw that the standard pivot table grouping and show values as features allowed us to create reports quickly. The limitations of the standard pivot table were that the formatting and the naming of the formula had to be redone each time we did a calculation. And we saw that some calculations like average monthly sales were very difficult with formulas and a standard pivot table. When we jump over to Power Pivot and DAX, you're not going to believe it. The formulas can have number formatting and a consistent name. And when we get to calculations like average monthly sales, it's a much simpler formula. Now, it's not just these cool DAX formulas that we're going to get to learn. We'll also see how to avoid using the XLOOKUP function to bring attributes from the lookup tables or dimension tables over to our one flat fact table. Instead, we build relationships between tables. Then we can have all 4 tables in our PivotTable Fields dialog box and drag and drop fields from any table. In addition, last video, we had to calculate this sales column in our flat fact table. Well, guess what? You don't even need to do that in DAX. Well, in DAX, here's the one formula that calculates that extra column and then adds it for the sum calculation in the pivot table. That means inside the formula, we just say, hey, I need this table. And instead of XLOOKUP, because there's a relationship, we use related, multiply it times units, and then SUMX knows to go through every row in the F sales, calculate the line sales, and then add it to get total sales. This all happens inside the pivot table. Also, this formula will have one consistent name, and it will always have the right number formatting. Now, that all sounds awesome and wonderful, and it is, but it does mean that you have to learn how to create a data model and build DAX formulas. Here's the 5 steps we used in our data analysis process last video. In this video, step 1 is get the data. We use Power Query. Step 2, we create our data model. But here we use DAX formulas, relationships, hide fields, and Power Query if necessary. Step 3, we create the reports. Based on the Power Pivot data model, we build our pivot table reports. Step 4, we create our visualizations. And step 5, when we get new data, we refresh with Power Query. Now, step 1 is to get the data. Now, Power Query in the Data Ribbon tab, that's what we use to import data and clean and transform the data before we get it to our data model. Our lookup or dimension tables for product and sales rep are already in the worksheet. But just like last video, our sales data comes from an external file. Now, last video, we started off with this file, and it had 3 years worth of data. And then later, when we got new data, the file had all the old data plus the new data. In this video, we want to see a different scenario. We're going to be given 3 text files, .csv for comma separated values. We'll need to import all 3 years, create our data model, reports, and visualizations. And then later, someone gives us just the new data for the new year. We simply add the new file to the folder location, click refresh, and Power Query updates everything. Now, one other important distinction we want to make here is this data set has a total of 800 records. That's not a lot of data. But as we look at the standard pivot table, Power Pivot, and Power BI, it's helpful to use a small data set as we learn all 3 tools. But if you actually get big data, millions of rows of data, then you got to use Power Pivot or Power BI. The data models in both Power Pivot and Power BI are specifically designed to deal with big data. And we'll see a great big data example in video number 4. The text files from last video were .txt with a tab delimiter. These are .csv. If we do our trick from last video, right-click, Open With, but I'm going to open with WordPad. We can see the delimiter is a comma, and that delimiter is splitting the data into 4 fields. When you download the files below the video, you'll unzip this folder. And if we look inside, that's the file we'll add later. If we look inside the Start folder, these are the 3 files we're going to import initially. If we click up in the address bar, that's the folder path that Power Query will memorize. Then Power Query will take all 3 proper data sets and append them one on top of the other to create a proper data set. And later when we add the other file, it'll just add the new data to the bottom. Now before we import our data, make sure you have the Power Pivot ribbon tab showing. Go to File, down to Options, over to Add-ins. In the Manage dropdown, select COM Add-in. Click Go. Make sure that Microsoft Power Pivot for Excel is checked. Now, once we have our Power Pivot tab in the Excel ribbon showing, we can't just click the Data Model button and start working on our data model, because we have to get the data into the data model. And the tool we use for that is the Get and Transform Queries and Connection Groups Power Query. In this way, Power Query and Power Pivot always work together to create a data analysis solution. Now to import multiple text files and append, we go to Data, Get and Transform, the Get Data dropdown, From File, and down here, From Folder. You want to navigate to the Start folder. So I'm going to double click. That's the address that Power Query will memorize. We click Open. Power Query is looking inside that folder and showing us all the files that it found. We want to click Transform. This opens up the Power Query window. The content column, if we click off to the side, not on the green binary word, but off to the side, we can see that each row is looking at a file in that folder. These are the attributes for that file. There's the name, there's the extension, and a bunch of other attributes. Over in the Query Setting pane in Properties, this is the name of the query. It's also going to be the name of the table that we load to the data model. Now we want to rename it F Sales. The F is for Fact Table. In data analysis, a fact table holds the values that you want to summarize. And since these are sales, we'll call it F Sales and Enter. Now we only have one applied step. And I want you to notice, last video we didn't look at this, but there's a formula bar, and every step uses a Power Query M-code function. Now we don't need to edit any of these because they will be created automatically. But you can see this one is called folder.files, and it contains our folder address. If you move that folder or you need to change it, you come to the source step gear icon and click. You can browse and change the address. When you click OK, then that address is changed in the folder.files function. Now the content column has the files that we want to append into a single proper data set, and we don't need any of these other columns. Now if we were in the Excel worksheet, we would highlight these columns and delete, but in Power Query they make it easier. We come to the content column, right-click the field name, and down to Remove Other Columns. And just like that, they're gone. Now over here, it added a new step, Table.SelectColumns function. Now we have a column with our 3 text proper data sets. And we can use this Combine Files button. Now this button works when you have text files that are proper data sets, and you want to append them into a single table. So we'll click. Now this Combine Files feature is going to build a bunch of code for us. But it wants to know, is it all right to use the first file and the first 200 rows from that file to build the code for us to append all the tables. Now, when you get TXT or CSV data, it's usually coming from a reliable source like a database, so that's fine. File origin, and very importantly, it got the delimiter right. If it didn't get it right, this process would not work. Now, when we click OK, Power Query will build a bunch of applied steps and queries for us. On the right, we can see these applied steps. On the left, we see a number of queries created. And down at the bottom is the fsales query, delivering an appended proper data set. All of it done automatically. Now, over here, Power Query got a sample file, created some code, and then made a custom function. And then down in fsales, if we go back through our query and look, here's the two steps that we created. It then, in the fourth step, invoked that custom function and used it on each row, and then completed 1, 2, 3 steps, including changing the data types. And there's our proper data set. Now, what's so amazing about all of these queries and applied steps is if we go back to step number 1, remember, we're pointing Power Query to a folder. Right now, it has 3 files. But later, when we drop new files into that folder, this first step will list however many files we have. And then Power Query will rerun every step. But this time, the proper data set will incorporate all the new data. All right, now we need to load this to the data model. We go up to Home, Close, Close and Load dropdown, Close and Load to. This opens up the Import Data dialog box. And down at the bottom is Add this data to the data model. We check and then immediately come up and select Only Create a Connection. This allows Power Query to run all the applied steps and queries to append the tables without loading the data to the worksheet. If you accidentally leave the default option Table selected and you load it to the data model, it'll load it to both places, the worksheet and the data model. And we don't want to load it to both locations, especially if you have big data, because the worksheet can only hold 1,000,000 rows. So when loading to the data model, check that, click Only Create a Connection, and then click OK. In the Queries and Connection pane, we can hover, and there it says Loaded to the data model, and there's our folder path. Up in the top, all of these queries are loaded as a connection only. They're used only as part of the transformation to append the tables. We can collapse this folder of queries up at the top. Now, we want to go have a preview of this data in the data model. And we can get to the data model by going to Data, Data Tools, the Manage Data Model button, or over in the Power Pivot Ribbon tab, we can click the Manage Data Model button. It opens up the Power Pivot for Excel window. We can see it has its own ribbon with tabs. Down here, it says fsales, and this is a preview of our data. Now, when we load the data to the data model, it gets loaded into a behind-the-scenes RAM memory columnar database. And this database compresses the data to a very small size. That's how it can handle big data. Now, the way the columnar database works is it takes each one of the columns. In our table, we have 4 columns. It stores them as a unique list. For the date column, there are 426 unique dates. Product ID and sales rep ID would have 4 each. And the units column has 187 unique items. That's a total of 621 bits of data it's storing. But the full table in the Excel worksheet, if there are 606 rows and 4 columns, that means 2,424 bits of data. So this columnar database, even on a small data set like this, has to store a lot less data. But on big databases, it's dramatic how much it can compress the data. Now, when it comes to analyzing later on, the columnar database creates a map that enables it to reconstruct records that are needed for analysis. Now, later we get to come back here and create our DAX formulas. Now, to jump back to Excel, you can use that button. Or if the window's smaller, you can simply click or you can use Alt-Tab to jump back to the last active window. Now we need to bring both of these tables into the data model. And although we could click inside the table and go to Power Pivot and use the Add to Data Model button, it's much better to use Power Query to import all your data, because the tools inside of Power Query for dealing with data are much better than in the Power Pivot user interface. So I'm going to click in a single cell. And in the Get and Transform Data group, we click From Table Range. This opens up the Power Query window. That name is fine. The two steps that are created, including the data types, are fine. And notice the 1.2 is the data type icon that represents a decimal number. This is a number with up to 15 decimals. For almost all numbers we use in calculations, we want to use the data type decimal number. Except if you have whole numbers. Then you use the 1, 2, 3 whole number data type. The currency data type is not like currency number formatting. This data type only allows up to 4 decimal places. And I'm not even sure why they called it currency. But luckily, when we get over to Power BI Desktop, the exact same data type is called fixed decimal number. Decimal, decimal, text, text, and whole number. Everything's looking good, so we go to Home, Close, Close and Load to. We do not want Table. We want only Create a Connection, add this to the data model. Click OK. We can hover, and we see that the data has been loaded to the data model. We click in one cell in D Sales Rep. Click the From Table Range button. The name is fine. The steps and the data types are looking good. Close and load to, only create a connection. Add this to the data model, and click OK. We can hover and see that it's been loaded to the data model. Using Power Query, we have completed step number 1, which is importing the data into the data model. Now we move on to step number 2, which is building the data model. We can use the Manage Data Model button to jump over to the Power Pivot for Excel window. We can see we have 1, 2, 3 tables. Now we need to go back to F sales because we actually need a 4th table. Now whereas in a standard pivot table, you can use the grouping feature for date calculations. In a data model pivot table in both Power Pivot and Power BI, we use a date table to make our date calculations. Now just as we have to have a lookup table or dimension table for product and sales rep, and these tables represent a unique list of all of the sales rep and all the products, the date table is going to have a unique list for every possible day for every year from the fact table. Once we have this date table, we'll be able to make more varied calculations and reports than we can with the standard pivot table. Now in Power Pivot, we can create a date table with a single click. When we get over to Power BI Desktop, we'll actually have to use DAX Formulas to create the date table. All right, here's the fact table. To one-click our way to a date table, we go up to Design, Calendars, the Date Table dropdown, and click New. When we click New, this builds a complete date table. It went through the fact table, found every possible year, and then gave us a unique list of every day in all those years. It also added these attribute columns like year, month number, month, and a number of others. Now, we created this with one click, but there is one disadvantage to a date table in Power Pivot, and that is when we get new data later, it doesn't automatically update. So every time you get new data, you have to remember to come to the Power Pivot for Excel window, Design, Calendars, Date dropdown, and click on Update Range, and then manually change the dates. Now we'll see how to do this later. Now over in Power BI Desktop, although we can't create the date table with a single click, when we use DAX Formulas, those will update automatically when we get new data. Now I want to come down and rename this table. So I'm going to double click, just like in Excel, and we'll name this DDate. Our next step is to create a relationship from the fact table to each one of our lookup or dimension tables. That way we can drag and drop any of these fields into the pivot table and make calculations between tables. Now Home, Ribbon tab, View, We're in Data View. Data View is where you view the tables and create your DAX formulas. When you want to create relationships, you go to Diagram View. Now, each one of these represents a table. Table name at the top, field names below. Later, we'll have formulas listed here also. We can move these field lists around. Here's the date table. When I expand it, notice it creates a date hierarchy. That means we can drag one field into the pivot table, and it will list multiple date attributes. Now, each one of our dimension tables has a unique list of products, sales reps, and dates. That means there's one of each on this side. Now, if we have one of each product here, of course, in the sales table, we hope that we have lots of duplicates of each product. Same here. Sales rep is listed once, but hopefully that sales rep has many sales. And also over here, a unique list of dates, but hopefully we have many sales for each one of those dates. That means we have a one-to-many relationship between each one of the dimension tables and the fact table. One side, many side. Now, to create the relationship, we can drag the unique list of product ID. This is also known as the primary key. We drag it over to the same column in the fact table that contains the duplicates, product ID to product ID. And there we see a one-to-many relationship. This is known as the primary key. This is the foreign key. We can do the same for the sales rep table. Sales rep ID from the one side over to the many side. Now, it actually doesn't matter. We can drag from the many side over to the one side. And Power Pivot's smart enough to know which is the one side and which is the many side. Now, we'll come back here later because we're going to hide columns or calculations that we don't want to appear over in the reporting area. But for now, our relationships are created. Now we can go over to Data View. And before we build our measures in the fact table, let's adjust our date table. Now, columns like month and year, day of week, and the name day of week, those may be perfect for you. If you drag this into a pivot table, you could get the total for all periods for the days of the week and see which day generates the most sales. You could also add extra columns like for fiscal periods. But for us, I don't need any of these columns. And since we're building a data model, we don't want to have extra columns because remember, this is all stored in that columnar database. And I don't want to waste extra space. Clicking on the first column, I'm going to hold Shift, click on the last column, and right-click, delete columns. Yes, I want to permanently delete them. Now we're left with 4 columns. The first column was automatically created when we click the button. The remaining 3 columns here were created, but they were created using DAX functions. If we click in the top cell of year, we can see the year function, the month function. Those are exactly the same as over in the Excel worksheet. But when we get to calculating the month name, in Excel, we would use the text function. But over here in DAX, they named the function format. Now, these are calculated columns, and we want to create our own calculated column. One of our calculations we're going to need requires that we have an end of the month calculation. To create a DAX calculated column, I double-click where it says Add Column, and we're going to name this End of Month and Enter. Now, when you create a DAX calculated column or later a DAX measure, you actually do not create them in the cells. You have to come up to the formula bar. And this will be the same in Power BI Desktop also. Now, the function for end of the month is the same as over in the worksheet. For the start date argument, we need to select the entire date field. And just like in Excel, we click at the top of the column. And properly, it puts the table name and then the field name in square brackets. But in the Excel formula, we had to have the @ symbol, the implicit intersection operator, for the formula to pick out the correct value from each row. But in a DAX calculated column, it happens automatically. You put in the table name and the field name in square brackets, and it uses something called row context to grab the correct value from each row. So at the end of our column, used in the start date argument, I type a comma. And if we want the end of this month, we put a 0. End of next month would be 1. End of last month would be -1. So that's our formula. And that formula is the same as over in Excel, except for we don't have to put that implicit intersection operator. When I hit Enter, the correct value is calculated for each row in the table. If we scroll down, we can see February is correctly shown as 2/28. Now, by default, a date shows up with date and time number formatting. And for both of these columns, it'll have no effect if we use them in the pivot table or in our calculations. But if you want to add number formatting to show just the date, Home, Formatting, and here's the Format dropdown. And you can do that if you'd like. Now, one other crazy thing. Although we use the proper convention of table and then field name in square brackets, and we will not deviate from that, the automatic date table feature does not follow that convention. Now, the reason why is this feature was built at the beginning of Power Pivot, and they never updated it. As we'll learn later when we create measures, we reserve square brackets when we're referring to measures in other formulas. But when we use columns, we use a table name and square brackets for field names. Back in diagram view, we have our 4 tables and our relationships. Now we need to create measures in the fact table. We go over to Data View, F Sales. We can pull this up. I'm going to expand one of the columns because in the measure grid, we're going to build all of our formulas called DAX measures that we're going to use in our pivot table. Now, as we talked about earlier, we don't even need to calculate a column for line sales. We can simply have one DAX measure that calculates the column and then totals it. And that's the formula we use in the pivot table. However, since we're learning this for the first time, I am going to show you 2 ways to accomplish the same goal, which is a total sales formula in the pivot table. The first one is 2 steps. You create a DAX calculated column, and then you create a measure that sums that column. And then we'll create the second measure. That's the one-step process. It does both in one formula. Now we'll start with the 2-step method, and we'll add a calculated column called line sales. And for every row in this table, we're going to take units, but we need the product price. And in DAX, because there's a relationship between product ID and the product ID column in the D product table, we'll see how to use the relationship to look up the product price. We double-click Add Column, type the name of this DAX calculated column, and Enter. When we create DAX formulas, we always have to use the formula bar. And the name of the lookup function to look up through a relationship is called related. I hit Tab, and the only argument is the column name, and I'm going to use down arrow, of the field that contains the item we want to look up. Now I'm going to close parentheses and hit Enter. All of these are product ID 2, looking up the correct price. And if we scroll down, we have lots of different product IDs and the related function using row context to see each product ID in each row. And then the relationship, it looked up the correct price for each row. Now, this lookup formula is pretty amazing because we didn't have to put the lookup value into the formula like we did with XLOOKUP. Because there's automatically a relationship between product ID in both tables, we just put the name of the column that has the thing we want to go get and bring back to this DAX calculated column. And through the relationship, it automatically retrieves the right price. Now we come up to the formula bar, and now we times, and I can simply click on units. And that's our formula for line sales. When I hit Enter, the automatic row context in the calculated column calculates the correct line sales for each row. Now this is the 2-step process, so now we create the measure to use in the pivot table. Now when you create a measure, you click in a cell and type the name of the calculation that you want to appear in the pivot table field list. So I'm going to type total sales. And notice when I type, it jumps me up to the formula bar. And in Excel and in Power BI, we use an equal sign before the name of the function. But when you create a DAX measure in Power Pivot, you have to use the assignment operator, $, and then you type the name of the function. I know that seems weird, but that's the way it works in Power Pivot. Now I can simply highlight line sales, close parentheses. And when I hit Enter, this shows me the grand overall total. However, when we drop it into the pivot table, it'll get the correct amount depending on the row, column, and filter conditions. Now we need to add number formatting. So I right-click, point to formatting, select number, use a separator. 2 decimals is fine. Click OK. And now that number formatting appears every time we use this measure. And the name of that formula will also appear. Now this is the 1 2-step method. And I did it just so we can visually see the amounts for every row. Because now we're going to do the 1-step method. And this is the preferred method when you create measures to use in the pivot table or over in Power BI in your visualizations. We're going to type the name. It shoots me up to the formula bar, colon, equal sign. And then instead of using the sum function, we're going to use the SUMX function, tab. It has 2 arguments, table and expression. The table, well, just as we had a table down here and added a calculated column, we have to tell SUMX what the table is. Type FS and then tab. The expression argument, that's where we put our formula. And we can use the exact same formula we used over here, related to look up the D product price, close parentheses, times F sales, and I'm going to get units. Now the SUMX function works exactly like the table and this calculated column, but instead it does it all in a single cell. SUMX takes that formula and iterates through all 606 rows using row context to pick out the correct units and to look up the correct price. It then calculates all 606 line sales numbers, and then the sum part of SUMX adds them to get the total. So when we close parentheses and hit Enter, we get the same grand total. Now we can add number formatting in the Home Ribbon tab formatting, and any of these options, or more format, number, use a separator, click OK. Now you have a choice between creating a DAX calculated column and summing, or using SUMX. The convention is to use SUMX. Now SUMX is an iterator function because it iterates over a table and then makes an aggregate calculation. And there are other iterator functions such as AVERAGEX, COUNTIFS, and CONCATENATEX. They all iterate over a table and then make an aggregate calculation. Now deciding on whether to use a DAX calculated column or a single measure is based on preference. But there is a difference. When you create this DAX calculated column, the values are stored in the Columnar database. When you create a 1-step measure and the values have to calculate in the formula, then when you drop it into the pivot table or change the conditions or criteria in the pivot table report, each time the formula has to recalculate. My rule of thumb is if my formula starts to calculate too slowly when I drop it into the pivot table, then I come and make a DAX calculated column and make my aggregate calculation in the 2-step method. Otherwise, I stick to the 1-step method. Now, if we go over to diagram view, we can see in F sales, there's our measures. Now, we want to build our first pivot table. Even though we're not done with our data modeling, we still have to hide some fields and add a bunch more measures. But we want to see the magic of DAX measures. Now, our first report, I want year and month. And actually, in this hierarchy, I want to get rid of date. So I'm going to come over and right-click Date, Remove from Hierarchy, Remove. And so now when we create our pivot table, we'll drag Date Hierarchy and then our total sales measures. Now we can create a Power Pivot Data Model PivotTable directly from the Power Pivot for Excel window by using this drop-down here. And this drop-down not only has pivot table and pivot charts, but a bunch of combination options. We're going to use the top option to create a pivot table. Now, this jumps us back to the Excel window with the Create Pivot Table dialog box open. We click Existing. Then we have to click Collapse. I want this on year, month, sales. B3. Click OK. Click OK again. And so now over here on this sheet in Excel, there's our pivot table area. And in the pivot table fields task pane, we can see all sorts of tables. The cylinder icon means these 4 tables were created with Power Query and were loaded to the data model. These 2 tables come from the Excel worksheet. They're not in the data model. If you try to use them with your data model, they will not work. You can actually hover your cursor over each one of these and get a message about the source. These tables up here say they're from a query. This one up here says connection, but that's the date table that was automatically created in the Power Pivot window. Now our report is going to come from DDate and FSales, and I'd like to move these over to the Active tab. So right-click, Show in Active. Right-click, Show in Active. When we go over to Active, collapse more fields. That is beautiful. In our PivotTable Fields task pane, we have 2 tables. We can drag and drop for each tables. And look at our measures. The f of x icon means this is not a field from a table, but it's a measure we can drag and drop. Now, we're going to take date hierarchy and drag it over to rows. We see our years, and underneath there are months. And we are eventually only going to use one of these, but for the time being, I want to show you that both of them work the same. So I'm going to check and check. They both go down to the values area. And that is amazing. We get the correct totals for each year and the grand total. The measures already have number formatting, and the labels at the top are exactly as we intended. Now for this 2-step method formula, the total sales without the spaces, I'm going to uncheck this. Now we're left with the SUMX formula. And we got to figure out how in the world did that SUMX formula, which is the same in every row, how did it know to calculate the correct yearly total and then get the grand total in the last row? Now the measure did it with something called filter context. If we consider that measure calculation right there, when we drop the measure into the pivot table, as soon as it saw the row condition 2021, the entire fact table was filtered down to just the records for 2021. And then the measure had a smaller table that it had to deal with when it made its row by row calculation and then summed. When the measure got down to the next row, that measure is not dealing with the whole fact table. It's only looking at the records for 2022. Now, if we compare how a DAX measure works to how Excel worksheet formulas work, DAX measures use filter context to always get as small a table as is necessary to make the calculation. But Excel worksheet formulas, if you highlight a column, it uses every single cell in that column every single time. Now, the way that the filtering takes place, if we consider that cell right there and that condition on the row, and we jump back to the Power Pivot window and look in diagram view, more specifically, when we drag the year field from the DDate table into the row area of the pivot table, this entire table becomes filtered down to just the days for the year 2021. And that filter flows through the one-to-many relationship and filters the fact table. Every time you drag a field from a dimension table into the row, column, or filter area in a pivot table, or over in Power BI Desktop into visualizations, every time you do that, the dimension table becomes filtered, and that filter is passed through the relationship over to the fact table. If we come back to our pivot table and expand, and click in the cell that has the measure that calculates total sales for March, this is how the filter context works. Here's the full date table with 1,095 rows. Here's the one-to-many relationship over to the fact table with 606 rows. As soon as this measure sees March, the date table is filtered down to 31 rows. And then it starts to move that filter across the one-to-many relationship. Once it hits the fact table is filtered down to just the dates for March. And in this case, there are only 4 rows. So then SUMX has much less calculating to do because there's only 4 rows. And that's the magic of DAX measures and filter context. Now we have some more data modeling to do, and we want to notice something about the fields in this field list. we're never going to drag product ID or sales rep ID into the pivot table. So if we want to be polite and build a user interface for the report creator, we should hide those fields. Also, line sales and units, those are number fields. And if you accidentally drag those to the values area, they create what's called an implicit measure. And there's a number of problems with implicit measures. To see what these problems are, let's drag line sales. Let's mistakenly drag line sales down to values. Sure enough, it calculates the correct amounts, but it doesn't have the number formatting. It doesn't have the name we want. And if I look over here, I don't see a reusable sum of line sales measure. Also, when we incorrectly create an implicit measure, if we ever share this with someone over in Power BI, all these beautiful measures that we create show up, but the implicit measures do not. Now, the other problem is this implicit measure, it actually shows up in our data model. So I'm going to Alt-Tab to jump back over to the data model, but I don't see it here. Data View, F Sales, I don't see it in the measure grid. And this terrible button, which should be on by default, I'm going to go to Advanced, and there it is, Show Implicit Measure. When I click this, and you could see that little blue icon that shows up over here also, that indicates that this was automatically created when a field was dragged to the values area. Now, when we click on it, we can see the problems. You can't edit the formula. You can't change the name down here. You can't add number formatting down here. And of course, this will not show up when we send it to Power BI. So the rule is, don't create implicit measures. Now, I always turn this on just in case I accidentally drop a field. Then at least I can see it over here. And right-click, delete. Delete from model. Now, very importantly, let's go over to Home, Diagram View. And we want to hide all of these fields. These are number fields. These fields we're never going to use. We don't drag date from F Sales. We drag date or any of these date attributes from the date dimension table. So I click on the first one, hold Shift, click on the last one, right-click, and hide from Client Tool. Over in Power BI, it says Hide in Report View. We can see that they're hidden. Now, cost and price, we're not going to use those. Supplier and product, those we want to be able to drag into the pivot table. But product ID, we're not going to use. So hold Control, click, right-click, hide from Client Tool. Right-click Sales Rep ID, hide from Client Tool. We're also never going to use month number. So right-click, hide from Client Tool. And now the PivotTable field list, our reporting area, is much easier to use. And we're not going to make mistakes by accidentally dragging and creating an implicit measure. Now here's our year monthly sales report. And last video, I told you that month names would not sort correctly in a data model pivot table. Well, when we created the automatic date table, Power Pivot created this month number column, but then it sorted month using the sort by column feature. And it said, hey, please sort this month column with text values by the month number column. And 1 to 12 will sort January to December in perfect order. Now, it's automatic in Power Pivot. When we get over to Power BI Desktop, we'll actually have to invoke the sort by column feature to get our month names to sort correctly. Now we have our report, and step 4 is to visualize. Now, last video, we created a line chart. And guess what? It's exactly the same with a data model pivot table. We click in a single cell, Insert, Charts. There's the line chart dropdown. We're going to select the first one, and there's our chart. We can move it. We can get rid of elements that don't help deliver the message. This is chart junk. I can select it and use the delete key. These field buttons we do not need. Right-click, hide all field buttons on chart. Click on the chart title. Up in the formula bar, we'll type our name, total sales. Click on the vertical axis, and we'll use our keyboard. And notice over here we have our pivot chart fields. When I Control 1, a second pane opens up, Format Axis. We come down to Number. Open it up, and we'll have 0 decimals, tab. And now we have our line chart that shows trends over time. And the beautiful thing about the connection between a pivot table and a pivot chart is if I come over here and collapse, the chart updates. All right, now we get to create our next report. Make sure the pivot table is selected. And over here, I want to look at the PivotTable field list. And guess what? I forgot to hide the DAX measure without the spaces. That was the two-step method we did just as we were learning DAX. And we don't need it in the reporting area, so let's go hide it. Back in the Power Pivot for Excel window, Data View, we select our measure and then right-click Hide from Client Tool. It's grayed out over here. And the PivotTable field list shows one measure. Now we get to create our next report. So we're going to go over to the region year sales report. I'll select cell B3. And because there's a data model in this Excel workbook, when we go up to Insert, Tables, and the drop-down for Pivot Table, there's an option for From the Data Model. Now, if you don't see these four data connectors, select Table Range. I'm going to select Data Model. We can also use the keyboard Alt-N-V, T for Table, D for Data Model. Now, this is the new dialog box, Pivot Table from Data Model. It already has the cell selected. Now, this dialog box is much easier than if we start the Data Model Pivot Table from the Power Pivot for Excel window, because it only takes one step rather than 4 steps. If you see this dialog box, then to create the Data Model Pivot Table, select the dialog button, use this workbook's data model. In either case, we click OK. Now we're going to use a number of the data model tables, and you can move them to active. If you decide to work in the All tab, we need to select Region from Sales Rep. Do not select this one. Select the one with the cylinder icon. I'm going to drag Region down to Rows. There's our unique list. Up in Date, I don't want the hierarchy. I want to open more fields, and I want to drag Year down to Rows. And then our measure, I can check. And that's the total sales by region and year. Now, the next calculation is we need to figure out the year-over-year change as a percentage. Now, last video, we saw the ridiculously easy show values as. In a standard pivot table, that's an amazing feature, and it's why we want to use the standard pivot table. When we get to a data model pivot table, we're actually going to have to figure out a DAX measure that can do the same thing. Now, fundamentally, what we need for a calculation like this is in that cell, I need the total sales for this year, but I also need the total sales for the previous year. Now, if we create a worksheet formula, notice we are allowed to just use cell references. That's the difference between the 2 years, and we compare it to the starting amount. And that gives us the correct decimal or percentage change. But we don't get cell references in DAX formulas. So what we're going to have to do is we still need the 2 different numbers in the same cell. We'll use the total sales measure for the D5 part. But for the D4 part, because of filter context, that means this 2022 flowing into the formula, we're going to have to change it from 2022 to 2021. And the way that you change filter context in DAX is to use the calculate function. So we'll jump back to our Power Pivot for Excel window. And in the F Sales Measure Grid, we're going to create a new measure. I'm going to call it Previous Period Sales, $=. And there it is. All you have to do is type C and then hit Tab to get to the most powerful function in DAX, Calculate. Now, the first argument expression, that's where we put the formula where we want to change the filter context. So I'm going to type a square bracket. And notice that even though we hid this measure, it still shows up in our dropdown. So we want the top one, Tab. Now I type a comma to get to the second argument, Filter. And this is where we put the filter that we want to change the filter context. Now remember, we want to change it from the current year dates to the dates 1 year back. And you're not going to believe this. There's an amazing function called SAMEPERIODLASTYEAR. And all it needs for the dates argument, I'm going to type DD, is the first column of the date table, Tab. And this function can take the 2022 dates that flow in from the row area of the pivot table and automatically throw them back a year. When we close parentheses, that means that same period last year for that 2022 cell is now delivering all the dates in the date table for 2021 to the filter argument. Those days are then used by Calculate to change the filter context for total sales. Now, we could type comma, and there are more filter arguments. And all of these arguments work in an AND logical test. But all we need, one filter to help change the filter context. So close parentheses and enter. Now, we don't need to add number formatting because we're just going to use this in other DAX formulas. But we do want to try it to verify that it's doing what we think it'll do. I'm going to drag it down to values. And sure enough, just like that, bam, it got the previous year's total sales. And whatever condition or criteria that we drag into the row, column, or filter area, that will work. Now we can uncheck this. Back here, I can right-click, Hide from Client Tool. And right below, we'll call this year-over-year percent change, colon, equal sign. And there's a great DAX function called divide. Now, for the numerator, we need to take the current year minus the previous year. So square bracket. Total sales minus square bracket. There's our previous period sales. So in the numerator, this will give us the difference between the 2 years, comma. And in the denominator, square bracket P, the previous year's sales. Now the alternative result, that's what you want the DAX formula to put in the cell if there's a divide by 0 error. If we omit it, it'll put a blank. And it actually uses the DAX blank function, which shows nothing. That's our formula. Close parentheses and enter. Now I want to add some number formatting. So up in the formatting group, I'll just click the %. Now we can test it. Now when I check this, it's going to give us the correct results for each year. But the totals are not correct, and we don't want them there. So we have to amend our formula. Now notice the year column here. There's exactly 1 year in the filter context, 1 year in the filter context. But in the California total, Washington total, and grand total, there's more than 1 year. So we're going to use the if function and say, hey, does the year column have one value? If it does, run the formula. Otherwise, show nothing. So up in the formula bar, we can use the if function. And then here's another great DAX function, has one value. Now we want DD. And there's the year column, close parentheses. So if there is only 1 year in the filter context, comma, we want our formula. Otherwise, and this argument will use the blank function to show nothing if we omit it. So we'll leave it out. Close parentheses and enter. Now it shows blank here because in the measure grid there is no filter context. It's the same as the grand total cell in the pivot table. It has all the years. In our pivot table, now we have the correct show values as calculation, but using DAX. And if we come over and drag a new condition to the row area, our DAX measure works perfectly. That 42% change is between Aspen 22 and Aspen 21. If you come off to the side and take end minus the start and compare it to the start, we get exactly the same thing. Now I'm going to uncheck product, and there's our finished report, just like we got with our standard pivot table last video, but now we're using DAX. Now for the next report, we're going to go to the average monthly sales by product sheet. And I've already started the Data Model PivotTable. In the Active tab, there's our two measures, and we have the date and product table with product and year in rows. Now, if we're going to calculate the average monthly sales for whatever condition we drop into the row area, we first have to calculate the total sales for each month before we make the average calculation. Now, last video we saw how difficult this is. We had to create an intermediate table before we made our average calculation. So for the Carlota product, we actually had to create a unique list of all the months and calculate the total sales, then make the average calculation. But with DAX formulas, it's easy to make that type of calculation because DAX has iterators like SUMX and AVERAGEX that have a table in the first argument. Now remember what SUMX did. It took the formula and iterated over every row in the F sales table to calculate the transaction or line sales, and then it added. When we get to AVERAGEX, there's an amazing DAX function called values, and it generates a unique list in the current filter context. So if we put end of the month column into the values function, for each row in the pivot table, it'll always generate a unique list of months. And then the formula, total sales, will iterate every row in the table, which is all the months, calculate the total sales, and then the AVERAGEX function will average those monthly amounts. All right, in the F sales measure grid, we'll start the formula, average monthly sales, and we'll use AVERAGEX, down arrow. And it needs a table in the first argument. And luckily, values delivers a table. And read the screen tip. Returns a one-column table that contains a unique list. And that's exactly what we want. So DD, and we'll down arrow to the column that we created specifically for this calculation. Tab, close parentheses. That's the table that, comma, the expression will iterate over. Square bracket. And there's our total sales. Close parentheses. And when we hit Enter, we can come down, right-click, Format. I'm going to add some number formatting. Change the name up here to indicate the unit. There's no filter context, so that's the average monthly sales for all years. Now with our pivot table selected, we can check. And there you go, the average monthly sales for Aspen in 2021, 2022, and all 3 years. Now, if we look at the Carlota 2021 measure calculation, although the formula is simple to create, there's a lot going on here. First, this measure sees the conditions and criteria coming from the row area of the pivot table. Here's the pivot table row conditions. The year 2021 flows into the formula, hits the values function, and filters the D date table. Now the end of the month column is just one column in that table. Here's what happens to the date table. All rows are filtered to show just dates for 2021. There's a unique list in the first column, but look at the end of the month column. The month is repeated for every day in January, and then February, and so on. So it's this column that the values function is looking at to generate a unique list. So it's the values function that allows us to create a table that has the correct grain or size to summarize the monthly totals. Then in the second argument of AVERAGEX, we have our measure. And the Carlota condition flows in and filters the fact table for every single measure so that only Carlota records are showing. Then as the measure iterates down the end of the month table, the month condition flows in to each one of the calculations. So in row 1, only records for Carlota in January 2021 are showing. In row 2, Carlota for February 2021 are showing. In the third row, the March Carlota records are showing. And that filtering process happens all the way down so that the total sales measure can calculate the correct monthly sales for Carlota. And then the AVERAGEX takes those numbers and creates the average. Now there's a special name when you take a measure and iterate over a table like this and allow the row by row condition to flow into the measure and affect the filter context. It's called context transition. And the cool thing is, and we'll simulate what the DAX formula does here, if the condition is 2022 and the product is Aspen, our one DAX AVERAGEX measure creates a completely new table to iterate over. And then the total sales measure calculates a new set of monthly totals and then calculates the average monthly sale. Now here's a warning about context transition. If you try to skip creating the measure, total sales in the measure grid, and then using it in your formula, and you try to type the formula out in the second argument of AVERAGEX, you will not get the correct results. And the reason why is the measure allows context transition to happen, allowing the row condition to affect the total sales calculation. When you use the straight formula, that context transition doesn't happen. The number we get is actually the total for Aspen for the entire year 2022. Because none of the individual month conditions can flow in, it's not allowed to get the monthly total for the particular product. It gets the grand overall total for every row. So instead of Aspen for January, it just gets the grand overall total 12 times. And of course, if you add the same number up 12 times and divide by 12, you get the grand overall total. And that's the incorrect answer here. Now, if you really want the formula in the second argument of AVERAGEX, if you wrap the calculate function around it, that forces context transition, because the calculate function is the only function that can change the filter context. And in this case, it's converting the row context into filter context. And in fact, every measure you ever create has a hidden calculate function wrapped around it. And that's why all measures automatically do context transition. And this pivot table illustrating this is in the finished Excel workbook that you can download below the video. Now let's take a look at what happens if I change the year to 2021. There are some zeros in our data set, and that average is including those zeros in the calculation. The DAX formula we created would not include those zeros because there are no records in the data set. That's the average with zeros. That's the average we got. However, it's not hard to amend the formula if you do want to include zeros. In the expression argument, since whatever we put there is going to iterate over the table, we use the if function and say, hey, if the measure is equal to 0, then I want you to put a 0 there. Otherwise, run the measure. And that will give us the averages including those zeros. Now for our fourth report, we're on the total sales by supplier and year sheet. Let's click in cell B3, Alt and V, T if you do not see this drop down, D if you do, and we're going to put our data model pivot table in cell B3, click OK. Now I want to show you what happens if you have one of these rogue tables that's not in the data model. If you accidentally check supplier, it does add the field, but notice it added a 1 to the name of this table. As soon as you realize you did this, you have to go over to the data model and delete the table that was automatically added. So there it is, product 1. And it will not work because it doesn't have a relationship, and it's a duplicate table. So if this happens, you right-click delete. Say yes. Most of the time, it's safer to bring things over to active. Right-click show in active. We'll do that for date. And the measure table, since I don't have any fields showing, is automatically inactive. And now we get to witness the beauty of a data model pivot table. We can drag fields from multiple tables and use our pre-made formulas. Check. It's already got number formatting in the name. My cross-tabulated report is done. Now that's our fourth report. I want to go back over to the region year report. We want to create a similar report to this where we calculate year over year change, but we want to do it by counting transactions. And in this formula, we'll learn about DAX variables. Now here's our formula for year over year change. And notice we used previous period, a measure, twice. If we click in the previous cell in the measure grid, we created it, and then we hid it and used it in our formula. Rather than creating two different formulas, if we have repeating formula elements like this, we can use a variable. Now the formula will be similar to this. However, instead of total sales, we're going to create a measure called frequency. So down in the measure grid, I type the name of the measure, colon, equal sign, and you're not going to believe this. Getting a count, like using COUNTIFS or the frequency function, is even easier in DAX because we get to use a function called COUNTROWS. And what makes COUNTROWS so amazing is that it counts rows. And if we put the fact table into COUNTROWS, it doesn't matter what condition or criteria we drop into the pivot table, because filter context filters that fact table, and COUNTROWS counts how many rows there are. So that's the supercharged COUNTIFS frequency function here in DAX. When I hit Enter, down in the measure grid, we get a count of every record in the table, 606. And now we'll create our year-over-year change for the frequency measure. Now this is going to be a long formula, so I'm going to pull the formula bar down, and we're going to try and format this also. Formatting the DAX measure can make it easier to read. Now we're going to start with the name, colon equal sign, and I'm going to try and format this. So I'm going to Shift Enter. That adds a new line. We type VAR. That means there's a variable, a space, and then the name, and then an equal sign. And I'm going to Shift Enter and create the variable on a new line. And the convention for formatting DAX formulas is to hit Tab. And the variable has to get the frequency from the previous period. So we type calculate, and the expression, that's our frequency, comma, and we need to change the filter context. And just as we did before, we'll use same period last year. That needs the first column of the date table, close parentheses. Now, wherever this formula is, even though it's a variable, filter context will flow in, same period will throw it back a year, and then frequency will be calculated for the previous period. Close parentheses. Now we Shift Enter, and I'm going to backspace. And now, after the variable where we want our formula, we type return. Shift Enter and Tab. We're going to use if, Shift Enter, Tab, has one value for the year. That's the logical test, comma, Shift Enter. Then we need divide. And it's a new function, so the convention is Shift Enter, Tab. And in the numerator, we need frequency. We need the difference between whatever this period is and our variable. And look at that. In the dropdown, it says XY. There's the numerator, comma, Shift Enter, previous. So we'll put previous period count in the denominator. Now to close off the parenthesis for divide, the convention is Shift Enter, backspace, and you put the parentheses directly below the function. And result if false, if we leave it out, it'll put a blank. So we're done with if, Shift Enter, backspace, and there's our formula. Now when I hit Enter, it'll actually, in Power Pivot, jump the variable up to the top line. So when I hit Enter, there's our formula. We get a blank down here because, of course, in the grand total or measure grid, there's lots of years. Now I want to format this, so I'm going to click that %. Now I got to show you a hot tip. This DAXFormatter.com website has been around for years, created by the smartest DAX guys in the world, Alberto Ferrari and Marco Russo. You paste your code here, click Format, and it formats it for you. And now with these two measures, we can create our final report in cell G3. Alt-N-V and D. And OK is highlighted, so I hit Enter. Now I'm going to be careful here. And in Date, more fields, I'll drag Year down to rows. Sales Rep, there's the region. I'm making sure that that cylinder is there. Region down below Year. And then our list of measures. I'm going to check frequency and year over year. And there's our finished frequency distribution. Now, we're all done with our reports and our data modeling. If we go back and remind ourselves, oh, yeah, we created a query, and we have a new file. Now, inside of Start, there's 3 files. But let's copy this and paste it. Now, remember, Power Query is looking at Start. So now it's going to see 4 files. And now we want to refresh. And this will be different than last video. Last video, we had to use Power Query to dump a table in the worksheet and then create a pivot table from the table. We had to refresh twice. Here, Power Query and the data model working together, all I have to do is refresh the query. Now, these tables didn't change, so all I'm going to do is click that refresh button. And it's broken. And the reason why is, and we mentioned this before, In Power Pivot, that date table does not automatically update. So we have to go back to the data model. We have to go to the date table sheet, design, date table dropdown, update range, and the end date is going to be 2024. Click OK. So now this is updated, and our reports are updated also. We can go and look at every one of the reports. That is absolutely amazing. Even back here on our line chart, there's our updated line chart. And in our queries and connections pane, we can see 858 rows. If we double click this query, it opens up the Power Query window. And if we go back and click on the source step, we can verify that sure enough, it got all 4 files. Now the last topic we want to cover is once we have a data model here in Power Pivot, I want to show you how to automatically send it to Power BI Desktop, which is a free download, and how to publish it to PowerBI.com, which requires that you have a Power BI Pro or higher license. Now, next video, we'll learn how to use Power BI. But here, we just want to see how to share. In Power BI Desktop, you go to File, down to Import. And here it is, Power Query, Power Pivot, Power View. Here's our file. I'm going to double click. This is warning you that it's not going to import everything from Excel, but it's going to import just what's in the data model. Click Start. I'm going to copy data. You could keep a connection if you want. And when you click Close and go over to Model, and after you move things around, that's the same model that we created over in Power Pivot, but now it's in Power BI Desktop. And next video, we'll learn how to use Power BI Desktop. Now, publishing to PowerBI.com is even more amazing than sharing it to Power BI Desktop. And here's why. If you create this model, all these beautiful measures and relationships, and you need to share it with people on your team, you just click the Publish button inside of the Excel Workbook, and then anyone on your team can access this through the PivotTable dropdown and make PivotTable reports from a single source of data truth stored at PowerBI.com. This is how easy it is. File, and you always wondered what Publish meant. Publish, you have to select a workspace that people have access to. I'm going to select this workspace, and it's the second option. When we click Export, it loads the data model to PowerBI.com. Down here, you can see it working. You can click this button to jump over to Power BI Online, and making sure you're in the correct workspace. There it is. So now this is stored online, and when you're logged into Excel, the PivotTable dropdown will offer this as an option. I'm in a blank workbook. I go to Insert, PivotTable dropdown, or the keyboard Alt and V. Earlier we used T for table, D for data model, but now we use B for Power BI Online. And when I click that B, it opens up Power BI Datasets. We type the name of whatever that data set is, and there it is. Now, when I click this, it is not going to download the data model. It's just giving us access through the PivotTable user interface. So I'm going to click, and there it is. We can check fields from different tables. We can select our measures, and bam, our report is complete. And the beauty of this, of course, is that we have a single location for this data model that everyone can access. No more sharing files, changing things. It's just in one universal location. Now we want to compare a Power Pivot Data Model Pivot Table to a standard pivot table. With the Data Model Pivot Table, you can have number formatting and a consistent name attached to the formula. You can avoid the two-step calculation process where you have a helper column and then an aggregation with a one-step measure like we saw with SUMX. Some complex calculations can be easier with DAX, like iterating over a table to pre-aggregate numbers before making an aggregate calculation. We saw that with AVERAGEX. Relationships can replace VLOOKUP and XLOOKUP. You can have multiple tables in the PivotTable Field task pane. You can deal with big data. You can share and send the data model over to Power BI. With the standard pivot table, they're just flat out fast and easy when you have less than about 50,000 rows of data. Now, of course, you can have 100,000 rows of data in the Excel worksheet and make a standard pivot table. But that Columnar database is so amazing at compressing data that 50,000 rows is a rule I loosely follow. The grouping feature in the standard pivot table is fast and easy for dates, times, and numbers. And the Show Values As feature has many calculations that are easier than the parallel DAX solution. You don't have to spend time building the data model with DAX formulas and a date table. And some reports, like a frequency distribution report for text data, are super fast and easy with a standard pivot table. All right, in this video, we saw the 5 steps for Power Pivot data analysis. The first one, use Power Query to import the data. The second step is to build the data model, adding the relationships, creating the date table, creating measures, and hiding the fields that we don't need in the reporting area. Then step 3, we created our data model pivot table reports. Step 4, we only had one visualization, but we visualized. And step 5, when we had new data, we refreshed and everything updated. All right, stay tuned for next video where we'll get to apply our data modeling and DAX skills from this video, but in Power BI Desktop, where visuals and interactivity are amazing.